Hello and welcome to all students. In this lecture, we learn about partial derivatives and we study about the mean value theorem for scalar field. After that, we see the proof of mean value theorem for scalar field and we solve some examples based on mean value theorem. Now, first of all, see the statement of mean value theorem. Statement is, let capital S be any non-empty subset of Rn. Let f from S to R be a scalar valued function. Let A belongs to S and U belongs to Rn and A plus ut belongs to S for all t greater equal 0 less equal 1. Suppose du f of a exists for all a plus ut where t greater equal 0 less equal 1, then there exists theta such that theta is greater than 0 less than 1 and f of a plus u minus f of a is equal to du f of z, where z is equal to a plus ut. Now see here, first of all we understand the statement of the mean value theorem for scalar field. So to define a scalar field, we need a non-empty subset S of Euclidean space Rn. Therefore, we have taken here one non-empty set S, and that scalar field, or we can say scalar valued function, that function is defined from the non-empty set S to the set of real numbers. Next, here point A is taken from the non-empty set S. A belongs to S and U is a vector in Euclidean space Rn. Also given that A plus ut, this linear combination, is belongs to S. For all t greater equal 0 less equal 1, and suppose the directional derivative of f at point A in the direction of vector u exists. Directional derivative is exist here for all a plus ut where t is greater equal 0 less equal 1. Then we have to show that there exists a theta such that theta is greater than 0 less than 1 and we satisfies this condition. F of a plus ut minus f of a is equal to is nothing but the directional derivative of f at point z in the direction of u where z is a plus u theta. So this is the statement of mean value theorem for scalar field. So we try to prove this theorem. Okay, so how to prove, we will see here. So see here, to prove the given theorem, we define a function g from closed interval 0, 1 to the set of real numbers. So we define one function g from closed interval 0, 1 to r, and it is defined like this: g of t is equal to f of a plus ut. G of t is equal to f of a plus ut. First we will prove that g is differentiable and g dash of t is equal to du f of a plus ut. Means g dash of t is nothing but is the directional derivative of f at point a plus ut in the direction of vector u. Okay, that we will prove. So let us take the derivative of g of t. Let us take a derivative of g of t is equal to, it is a ordinary derivative. It is equal to limit h tends to 0 g of t plus h minus g of t divided by h. But g of t, that function is defined above like this: g of t is equal to f of a plus ut. So by definition of function g, we write this function here. In the next step, in the second step, limit h tends to 0 f of g of t plus h ची व्हॅल्यू आपण इथे लिहिणार आहोत f of a plus t plus h into u minus g of t is f of a plus tu or ut. You can write ut or tu, no problem. In the third step, it is equal to limit h tends to 0, and if we simplify the inside bracket of f of a plus tu plus hu minus f of a plus tu. So let us write a dash for a plus tu. So our next step will be limit h tends to 0 f of a dash plus hu minus f of a dash divided by h. So this limit is nothing but the directional derivative of f at point a dash in the direction of vector u. So see here, it is very simple and it is very easy to understand. The g dash of t, it will give a directional derivative of function f in the direction of u at point a dash. Here a dash is a plus tu, and thus g dash of t is equal to directional derivative of f at point a dash in the direction of u, or we can say that g dash of t is equal to directional derivative of f at point a plus tu, or you can say ut in the direction of vector u. So we have proved this thing. This last step, keep in mind, g dash of t is equal to du f of a plus tu. Okay, so keep in mind, or we call it is equation star. We call it is equation star. Now consider, apply one dimensional mean value theorem to the function g. Now apply one dimensional mean value theorem to the function g in the interval 0, 1. So we know that one dimensional mean value theorem, g dash of theta is equal to g of 1 minus g of 0 is equal to g dash of theta. Theta lies between 0 and 1. Here it is not g of theta, it is g of 0. Okay, but g of 1 is f of a plus u, and g of 0 is f of a. So therefore finally what we have is, and also we have g dash of theta is equal to du f of a plus theta u. So hence f of a plus u minus f of a is equal to what we have is this thing, g of 0 is f of a. So finally g of 1 is f of a plus u minus f of theta, and g dash of theta is, it is nothing but du f of a plus theta u. So thus we have proved this thing. Mean value theorem is proved here for a scalar valued function f. Okay, here f of a plus u minus f of a is equal to du f of a plus theta u. Here z is equal to a plus u theta. If I put z is equal to a plus u theta, then f of a plus u minus f of a is equal to du f of z, where z is a plus u theta, where theta lies between 0 and 1. This is very simple proof that we have given here. Okay, so based on this proof we have to solve some problems. Okay, now in the next slide we take one problem based on this theorem. Okay, let us take one example now. Example question number 1. Find the real value theta in 0, 1 if it exists, satisfying the condition f of a plus u minus f of a is equal to du f of a plus theta u for the following function is given. F of x comma y is equal to x square plus y square. Point A is given, a is equal to 0, 0, and vector u is given minus 1, 1. So given data is f of x comma y is equal to x square plus y square. Point is given, a is equal to x square. Point is given, a is equal to 0, 0, and vector u is equal to minus 1, 1. So keep in mind all these values and function x square plus y square. So here condition is given that f of a plus u minus f of a, we have to find a theta, value of theta. We satisfy this condition. F of a plus u minus f of a is equal to du f of a plus theta u. Okay, so we have to find out value of theta. We satisfy this condition for a given function, given point and given vector. So here we find, so first of all we find what is a plus u. So a is given 0, 0 point, plus u is a point or vector minus 1, 1. So if we add these two vectors, you will get minus 1, 1. So a plus u is equal to minus 1, 1. We will use this in the next slide. Now f of a plus u is equal to f of minus 1, 1. But function is defined above like this: f of x comma y is equal to x square plus y square. Therefore f of minus 1, 1 we can write like this: minus 1 square, not raised to 1, minus 1 square plus 1 square, it is equal to 2. And now find out f of a is equal to f of 0, 0 is equal to 0 square plus 0 square is equal to 1. Here is I think some mistake. 0 raised to 1 is written, but it is not 0 raised to 1. It must be a 0 square. 0 square plus 0 square, and final answer is 0. Okay. Now here a plus u theta is equal to, a is 0, 0 plus theta into bracket minus 1, 1 is equal to minus theta, theta. Okay, so a plus u theta is equal to minus theta, theta. Now write the directional derivative of f at point a plus theta u in the direction of u is equal to limit t tends to 0. By the definition of directional derivative, it is written like this: the directional derivative of function f at point a plus theta u in the direction of u, it is equal to limit t tends to 0 f of a plus theta u plus ut minus f of a plus theta u divided by t in the next step equal to limit t tends to 0 f of a plus theta u is minus theta comma theta plus u is minus 1 comma 1 into t minus f of minus theta comma theta divided by t, it is equal to limit t tends to 0 f of minus theta comma theta plus minus t comma t minus f of minus theta comma theta divided by t equal to limit t tends to 0 f of minus theta minus t comma theta plus t minus f of minus theta theta. But our function f is defined above like this: first component square plus second component square. So in the next step, limit t tends to 0, first component is minus theta minus t its square plus second component is theta plus t its square minus, now f of minus theta comma theta is nothing but minus first component square minus second component square divided by t. It is equal to limit 2 times theta t plus t square plus 2 times theta t plus t square. So theta square will get cancelled and it remains only 2 times theta t plus t square plus 2 times theta t plus t square divided by t. So if we divide by t, then what is left in the numerator, it is 4 theta plus 2t, and if I take a limit as t tends to 0, it remains 4 theta. Okay, so finally we have du f of a plus theta u means directional derivative of f at a plus theta u in the direction of vector u is equal to 4 times theta. Now consider f of a plus u minus f of a is equal to du f of a plus theta u. But f of a plus u, we already calculated it is equal to 2, and f of a is 0. We calculated above, it is equal to 4 theta. So 2 minus 4 theta. In the next step, 2 divided by 4 is equal to theta, and therefore theta is equal to 1/2. Theta is equal to 1/2. So in this way, we will find in the value of theta which satisfies this condition. So here, so this is our problem. So here what problem says that find the real value theta if it exists satisfying the condition f of a plus u minus f of a is equal to du f of a plus theta u. तर अशा पद्धतीने आपल्याला थीटाची व्हॅल्यू काढायची आहे फॉर दिलेल्या फंक्शनसाठी आणि पॉईंट आणि व्हेक्टरसाठी. वी सॅटिस्फाय दिस कंडिशन. ओके, वी सॅटिस्फाय दिस मीन व्हॅल्यू थेरम. So here we found a value of theta we satisfy the given condition, and the value of theta is equal to 1/2. Now based on this, let us take one example as a homework to you. Question number 2, find the real value theta in 0,1 if it exists satisfying the condition f of a plus u minus f of a is equal to du f of a plus theta u for the following function. For the following means one function is given to you f of x comma y comma z is equal to xy plus yz plus zx, and point A is given. A is equal to 0 comma 0 comma 0, and vector u is equal to 2 comma 1 comma 1. So we have seen in the previous problem the way of finding value of theta. You follow this way, we follow this procedure and try to find the value of theta. We satisfy the mean value theorem, satisfying the mean value theorem for the scalar valued function. Okay, so in this way we will now stop our lecture, and thank you very much.